Hello, my name is Tony Xu, and I am a junior studying computer science with a minor in data science. Today, I'll be going over loss function and why loss function is so important in model prediction. To see the motivation behind loss function, I want to use a very relevant prediction model, that is the recommendation model. You might wonder, how does Netflix recommend movies to people? Well, how they do it is they will collect users' data on their rating for a bunch of movies and feed them into their machine learning algorithm. And from there, as the new user data comes in, they would uh, predict ratings for a bunch of different movies and recommend user on the highest rated predicted movies. So here we have a nice linear regression model. It's simple, yet it's very powerful. So we have different datas, data 1, data 2, data 3. Those are the weight for the features. And here we have the corresponding features. One, which is the indicator function that tells you if the movie has Brad Pitt and if the user is female, as well as the box revenue of that particular movie. So what do I mean by weight of the feature? Well, um, for example, if you want to prioritize the indicator function because you feel that the box revenue function is not as important because it's not personalized, then you will give more weight towards that particular parameter. So if we knew the true parameters, meaning if we knew the weights, how much to give each feature, then we can simply plug in uh, the input user data and the parameters, and from there we'll be able to compute a nice predicted rating. But the issue is that we don't have those true parameters, right? And this is where the loss function comes in. So loss function is a mathematical description that gets you a value, sort of describe the difference between the true value and the predicted value. Um, and the smaller the loss function value is, the better your model is. And here we have three very common loss functions. We have the L2 loss, the square loss, the absolute loss, and the Hooper loss. I won't go into too much detail into them, but each one has its own pros and cons, and depends on your problem, you might find one that's more appropriate for your model. So the loss is defined as the data, the parameter, and the y, which is the data point. From there, you will compute the difference and then square that difference to get you the square loss. So since we're talking about entire data set of people, it makes sense for us to compute the average loss on each record. Um, so what happened is we apply the loss function into each data point, compute the loss, sum up all the loss, divide by n, and that will give us the average loss of this data record. So here we can see that D contains the set of n different data points. So as you can see, we're sort of dealing with this optimization problem, right? Because we want to minimize the loss as to be small as possible, so we can fit our true value, fit our predicted value to closer to our true value. So the general procedure is that first you want to verify that the function is convex. Because of time, I won't go into what convex functions are. Second, you want to compute the derivative. And third, you want to set the derivative equal to 0. And that would be your optimal parameter. Why is that? It's because that's a property of the convex function, that whenever the derivative is equal to 0, at that point, your value is minimized. So lastly, I just want to quickly go over an example on minimizing the L2 loss. So first we have the definition of the average loss. Second, we have the derivative of the average loss. And lastly, we have setting the derivative equal to 0 and solve for our optimal data hat. Interestingly, that's actually the mean of our data set. So that concludes our brief introduction to loss function. If you have any questions, feel free to email me. I want to credit Professor Gonzalez and Perez for these slides. Thank you for watching and have a nice day.